present a talk for the building apps for the billions. As India is a billion people country, whatever app we build, it will be live for billion users. So we wanted to provide the best experience for that. I'm presently working with Swiggy, that is a food tech delivery company, and I'm managing the Android team there, that is the consumer-facing apps. You can find me in Medium and at Twitter. So the idea is building apps for billions. Let's start. So I will cover a few topics. The first one is how we can optimize the app launch optimizations. Network response, if your app is making the call to server, how we can optimize it. Image optimizations, as the app is image heavy. Optimization specifically for India, how we have done optimizations for India. What are the best practices for app build time for the developers, app stability for the end user, app adoption for end user, app size, because data costs a lot, and summary. So let me start with the app launch optimizations. So why app launch matters a lot? If you see, most of the user drop off during the app launch if they are not able to see any content. Another analysis done by the App Dynamics is like 87% of people already drop out if they don't see any experience. If your app is taking more than 11 seconds, most of the people will drop out. If you see the companies like Google, Amazon, for Google, if they increase the latency by every 500 milliseconds, they see a drop of 20%, plus people will move to different search engine. Amazon, the same case, if they see any latency increase of 100 milliseconds, they saw a drop in their sale. People start using the different app in case if they start seeing the latency in the app. So how we solve the latency problem in our app? So I will start with the splash screen. So splash screen is the first part that user will see when he launches the app. So these are all the best practices that we figure out during our 2 years of app launch optimization journey. So earlier we used to have a splash screen. We used to show a fancy image, a very big image, very rich image. So we have using bundling the 1 MB of image with our splash screen. When we run the memory profiler for it, we figure out that that splash screen is taking a lot of memory footprint when the user is launching the app. Even on lower end devices, user not able to move after the splash screen because loading that image in the splash screen itself causing the crash. Migrated our heavy splash screen image to the launcher icon. So if you see, we replace 1 MB image with the 10 KB, it's just fast. It will load fast. Next we come is that SDK initialization. Every app is using the SDK like we are using Fabric, we are using Firebase, we are using monitoring SDK, we are using SDK for push notification, deep link, any other things. We have migrated all our SDK initialization to background. When we do it, figure out that we are using Facebook SDK, it's auto-initializing, and it's causing 200 millisecond delay in the main thread. Migrated it to background. We migrated Fabric to the background. It has given us 250 millisecond improvement. We migrated all other SDK, whatever third-party SDK we are using, like we are using New Relic for monitoring, we migrated it, AppsFly we migrated. And we have seen the improvement of like 300 to 500 milliseconds just by migrating all these things. There is no drop in the tracking or any issue presently by moving it to the background thread. Now, how we want to unblock the main thread? In Android, we only have one main thread, and we have multiple background threads. We want to optimize the main thread so that all the operations, only the minimal operations will happen on the main thread. First step, we figure out that we are doing too many JSON serialization, deserialization. Migrated all of them to the background. Next is that we have the JSON classes. We have like 1,000 of POJO models, and we are doing JSON serialization, deserialization for that. Now there comes a library which is stack. That solved our problem. What exactly stack will do? It will create the type adapter for all the JSON serialization, deserialization, and it avoids the reflection. We have like 1,000 POJO. We can't write the custom type adapter for each of one. Stack provides the annotation. The stack is available for both Java and Kotlin. You can just use the annotation in your POJO and it will automatically write the type adapter. It does have impact on app size because you are writing the type adapter for like all the Pojo classes, but yes, it has given us the benefit in terms of app launch time. So we have seen around improvement of 200 to 300 milliseconds. Another thing is how we can initialize the things lazily. Lazy initialization means you will initialize the SDK only when the event is created. We have analytics SDK, we are using like 2 to 3 analytics SDK. We only initialize it when the first event is created. If there is no first event, we don't even initialize the SDK. We are using the different fonts for showing up in the UI. We only initialize it when it's required. Not all the fonts are required for homepage rendering. Migrated it, and we have seen the improvement of like 100 milliseconds. Next comes lazy apply. We used to show a lot of this experience to the first-time user, repeated users. We wanted to ask them to rate our app. We asked them to update the app to latest version. Earlier, we used to show this pop-up on homepage, show the same to the user. User will see it. But now what we are doing is that we do all this calculation in the background. Whether user wants to show the rate the app, user wants to update the app. If it's coming out as true, then only we will show the experience. Earlier, we used to make a network API call, make a blocking call to show all this experience, which is now moved to the background thread. And it will be applied lazily. It's not required for the first-time app launch. AB configurations. All the apps are using the AB, and we need AB for our app and for all the pages. One of the things that we figure out is that we are making a blocking call for the AB, and without AB call, we are not letting the user go to the home page. Do we really need the AB call for the user to see the data? No. We can make the call in the background, get the data, and apply it next time the user coming to home page. We made the changes. We have seen the improvement of like 500 to 700 milliseconds. But there are companies which are like Hotstar, which have like 500 million plus installed. They have seen the improvement of like 4 to 5 seconds on 2G network. Till 5 seconds, they are just blocking the user for that AB call and not showing any data to the user. So they are using the Firebase remote config. They are doing all the things on main thread. They migrated it to background thread, lazily applied it, and seen the improvement. Now comes cart and user details. This is the bottom bar of our app, and we have like near you, search, cart, account details. What exactly we are doing is that all the data, we show the icon on the cart if you have any items on the cart. If you have any update in the account, which used to show the dots there, we'll make the API call for all of that lazily. That should be happen only when we have the homepage response call. We'll not make the Peller call that will fight with the homepage response for showing the data for the cart and account. Blocking calls. We do have a blocking calls like you wanted to validate whether the user is valid, whether the device is valid. Yes, we also do the same, but we will not make it a blocking call. We'll do it in the background. If user is not liable, device is not working, we'll show the pop-up to him, but that's not a blocking. User can still see the home page. We do pre-initialize some of the pages, like if we are using the React Native for our internal pages, and what we have seen is that React Native needs to initialize the VM. What we have done is that if we know the next page is React Native, we pre-initialize that VM so that the React Native page will be loaded faster. Do we have tools to analyze all this? Yes, we do have tools. We have Firebase Puff SDK, we have Systrace, we have the Studio Monitoring. There's another tool, which is the paid one, which is NimbleDroid. NimbleDroid is the tool, if you upload the app, it will give you the methods which are blocking the UI thread, which are blocking the main thread, and how much time for that it is blocking. It's a paid tool. You can go try. It will show the graph of your launch time versus the other peers plus other details. So this is how the experience will look like. If you see, earlier we used to have the splash screen, making too many blocking calls, user not able to see the delivery location itself. So we have seen like 53% reduction in our launch time, and it's as fast as seamless as it can be. Now the next come is that your app always interact with the server to get the data. how we have optimized the network response time. The more the time your data will take to get it from the network, the more time it will take to show the data to the user. So what we have done, we are earlier using the HTTP 1.1. We recently migrated to HTTP 2. And we have seen some major improvement in terms of network response time. HTTP 2 will provide the multiplexing and the header optimizations. And when we applied it on all our host domain, we see the result. So we have like 3 to 4 domain. We applied it on all the hosts. And we have seen like 20% improvement in the network response time. So if you see the earlier, we used to have 1 second of time. It's now reduced to like 0.8 to 0.75 seconds. So we, just by adding the support of HTTP2, we have seen 20 to 25% improvement. And OK HTTP by default provide the HTTP2 support. Just have to enable it from the backend. So this is the improvement for the another host. So where we have seen like 20%. We have seen 25% also for one of the hosts. So how HTTP2 gives that advantage? So if you see without HTTP2, for all the further requests that we are doing, we have to do the time for DNS connect and the TLS handshake. So we ended up adding the time for it in every API call. With HTTP2, all DNS connect and TLS handshake time will be removed for the subsequent API calls. All that time optimizations will be done for all the API calls. So if you have single host, you are pointing all your API to that. If you enable it, whatever the API calls you are getting and you are hitting the server, you will be expected to get 20 to 25% improvement in your response time. gzip compression. So all the network requests, we make sure that we followed the gzip compression. With gzip, we have seen like 75 to 80% drop in the network response time and the payload side. Ignore null field in the payload. What exactly is the null field? Our response comprises of JSON that is many field. So we have nullable field, we have null field, some of the fields. What we tried out, if the field is null, we don't even send the field in the response. Client will assume that the field is null, and it will handle that case. So when we remove the null fields, you have the Jackson ignore method. You can remove all the nullable field from the response. Based on how many times you are sending the null field in the response, it will give you the improvement. In our case, we have seen like 3 to 5% reduction in payload size. So, but by just removing all the nullable field which are coming in the response, we have seen that improvement. Next comes protocol buffer. As we are already doing the gzip compression, we tried out the protocol buffer as well. With protocol buffer, we have seen the reduction in payload size, huge reduction in JSON serialization, deserialization. The problem that we haven't seen the much improvement in terms of result because we don't have many integer fields and the Boolean. The JSON comprises mostly of the string, due to which we have seen like 5% improvement in our page rendering time that comprises of serialization, deserialization, and the payload over the network. Implement 304 status code for API. What we are doing is that whatever the data is coming from the API, we have the checksum logic with that. Checksum is basically the hash of the response. Next time, if we are making the same API call, we pass the checksum to the server. If there is no data change, server will return back 304. It avoids passing the same data over the network to the user. User will have less memory footprint. You don't need to pass the same data over the network again and again. We have enabled the caching at network layer. You can enable that caching at network layer. If you are not using the DB layer caching, you can enable it. Retrofit provides it, and you can enable it for like 2 minutes, 3 minutes, based on the API calls. Combine API calls. When we started making the app, we are making the multiple calls to different domain, different host. And for rendering one page itself, we are making 10 to 15 calls. What we figure out is that, so this is how we are making. So let's say if I have a home page, I wanted to show ads in that. I wanted to show personalization. I wanted to show recommendation, merchandising, every data. What earlier we are doing is that from app side, I'm opening 4 TCP connection, making all 4 requests, getting the data, combining it, and then showing it to the UI. The result of that is that I'm ended up making 4 TCP connection. All calls are blocking calls. If there's not one call is coming, I have still wait for that so that user can see all the data combined. Now, the change that we have done is that we migrated all the things to mobile intelligence server there. What exactly is mobile intelligence server there? Let's say I have 4 clients. I have Android, I have iOS, I have web, and desktop. All 4 clients will interact with that mobile intelligence server. They will pass the information, which platform it is, which OS version it is, which app version, user detail, user make and model. Now that mobile intelligence server will interact with all the domain, all the system which are present in backend, take the response from each one of them, and pass it on to the different clients. One of the logic that we have added, we have like 300 millisecond TTL for all the API calls. If any of the backend is not able to return the response in 300 milliseconds, we'll drop the request for it. Now that mobile intelligence server, based on the response he gets from all the backend, combine it and present it to the UI. UI don't have to do any logic for combining data, checking the, rechanging the position of it, opening multiple TCP connections. No, we don't have to do. All that thing will be managed by one server. He knows which client are you. He can change the response. He can add any logic at that layer. So earlier we used to have like mobile only. Now with this logic, we can support and scale all our 4 apps without doing any change in the app. Now comes image. Image plays a very big part in most of the apps, as most of the apps are image heavy. So showing the right image, right quality image, plus showing how fast we can show will provide a better user experience for the user. We have done some of the optimization for the images. We enabled the HTTP2 for the images as well, and we are seeing the 20 to 25% reduction same we are getting for other network. We migrated all of our images to WebP. Even though we are downloading the image over the network, we download only the WebP image. We're not downloading the JPEG PNG images. Seeing like 25 to 30% smaller size. More QPS it can support because it will take less time for the server to respond back. Less data consumption for the user as well. Another optimization that we have done is that we show image placeholder. So if you see, we have like a solid background as a placeholder. We have one background image. We just change the color of it, random color, and show it to the user till the time we download the image. We are also planning to match that background color with the image of the color. So that part is in work in progress. We are planning to move to it. Another is that we can download the low quality image placeholder. Presently, we are downloading 3% of the actual image size for showing the placeholder. And the best technique is like to use the 200 bytes download, which Facebook is using. What exactly it will do, with the current page response itself, you can send the 200 bytes response for the images. You can show the placeholder image, and then only make the request for the better image quality. With that, you can avoid the multiple TCP connection for the placeholder request. So with the response itself, you can pass the image payload. And if it's 200 bytes, let's say if you have 10 images which are in viewport, you ended up owning only the 2 KB of extra response. There comes the quality range for the image. So what we are doing is that whenever we have the image, based on your network condition, based on how good the network is, we change the quality of image, and then we will show the right image to the user. If you see the image here, if we download the image with quality 10, we see a size of like 6.4 KB. It has some image compression logic, due to which it's showing the blurred. If I download the image with quality 90, it's 48 KB. It's not that huge size. So based on your network quality, we'll change the quality of the image, download the right image. We use the quality 10 to show the blurred image to the user, that is the image placeholder. We show the quality 90 to show the best image to the user if you are on Wi-Fi network, 4G network, and on a very good network speed. If you see, we have the quality 100 as well. So if you see, the quality 100 is like 228 KB, whereas quality 90 is like 48 KB. There's a 80% size difference between the quality 100 and quality 90. So even if you are on the good network, we avoid downloading the quality 100 image. It will has a huge impact on your data cost plus memory footprint. So we never download the quality 100 image. Bucketing image dimension. Bucketing image dimension is the thing we tried on top of your quality. So we have like multiple image views inside the app. If we calculate the image view width and height and download the image based on that, we ended up making up too many dimensions to the network. So what we have done is that based on your image view width height, we bucket the images. Let's say if you have an image view width height is like 92, 92, another is 96, 96, we sample it to 100 cross 100 bucket. So we download a 100 cross 100 image that can be reused for 96 cross 96, that can be reused for the 92, 92. So on that way, we added the bucketing logic so that we don't ended up making too many requests call for different dimensions. So you have the bucketing logic, divide the buckets into multiple parts. Network condition. So we calculate the user network condition based on the response, downstream response time, plus current network state, and based on that, we'll change the quality of the image. We have done some optimizations specifically for India. So why India? We have seen the flaky network in India. People use the app who are using 2G, 3G, 4G Wi-Fi. So we have done some more optimization on top of it for the India. We change the image quality based on your network. We start batching the real-time event. In our app, we have some events which we want to be fire real-time. For that events, the connection will always be open. You always send the event when it's get fire. If the user is in very bad network, we start batching all that event and send it in batching. So let's say if I have to fire the 10 events, instead of opening 10 connection, instead of passing it 10 times, I just batch it and pass all the 10 events in one time. We changed the exponential network retry policy. So we wanted to retry 3 times. In case of 2G network, we wanted to retry 6 times, but the retry timeouts should be less. Pass the network speed information to backend. Why we need to pass the network speed information? Let's say backend wants to enable, disable any service, they can do it without the intervention of the user. Backend should be intelligent, they should know the user speed. Based on that, they can decide whether we wanted to show the video to the user or not, whether we want to autoplay the video, whether we want user to play around with the push notification and other part, because user is already on the bad network. We also do the pre-phasing of the pagination. Let's say if you are on the bad network, if you wanted to scroll the pagination, we wanted to pre-phase the data so that the experience will be better for you. Web view optimizations. So we have the native app, but some of the pages are still web view. We're using the web view pages still. So how we have done the optimization for that? Web view pages will comprise of JS resources, images, fonts, everything. What we have done is that all that data, we will cache it, we'll bundle it with the app. We only download the delta changes of that pages over the server. Once the app launch happen, user is using the app homepage, make the call for that in the background, we pass the last checksum, get the delta update only, and store it in the file. Now, next time when you try to launch the web view, we intercept it and inject all that data. How much improvement we have seen? We have seen like 35% improvement with this change. So we enable the caching in our web view. We have seen the 35% improvement in web view launch time. Next, some app build time. So all this covers like the optimization we have done for improving the app launch time, network response improvement, image optimizations. Now comes for the part of the developers. So what are the best practices that we tried out to improve the developers' time and how to improve our app build time? So we separated out debug flavor, release flavor. Release flavor is for the live user, debug is for the developer. We disabled all the things in the debug flavor. You don't have Fabric, you don't have New Relic, you don't have Firebase, you don't have any static code analysis tool on the debug. So when you run the Crashlytics, let's say if you run the Crashlytics, if you see the Crashlytics upload the mapping.file to the Crashlytics server, that takes a lot of time. So we disabled that. Firebase run a lot of perf test and dexing one during the build time. We disabled. We don't need it during the developer time. So we disabled all of that. We don't need the static code analysis check during the developer time. We started applying the full version for the library. Let's say if you are using the library, start avoiding providing .star. Give the full version of the library. It will avoid downloading and checking for the latest version of that library. We have the release version, enable the ProGuard, shrink resources, minify, everything on the release version, but not on the debug build. Next comes the default property. So we have added the check is like whether it's a release build, whether it's a fast build or not. Based on that, we change the min SDK version, Fabric, resource config, your default config, all that thing. Dagger, we stopped the, if you guys are using the Dagger, we stopped the formatting for the Dagger during the developer build, and we enabled the fast init for the Dagger. Now, next comes the modularization. So what we have done is that we divided our code into 10 to 15 modules. So the advantage of modularization is that whenever, if you change the code in one of the module, don't need to compile the other modules. So we migrated all our modules to the Artifactory, and we are using that Artifactory in the Gradle. So whenever we update one module, we don't need to update. We don't need to recompile the codes of other module. Create separate module for Java and Kotlin. If you create the same one, it will take more time. Important. Why modularization is important is that if in the future you wanted to have dynamic delivery of feature, you have to divide your app into different modules so that you can support the dynamic delivery of features. Next is like, so we have seen like 40% improvement in our app build time. That is the fresh app build time plus the incremental one. So we have seen the improvement in both of them. Now comes the next is app stability. So how stable your app is. So now we have done the optimization for the build time. Now developers are working on improving the app. So how stable your app is. So stability you can check in many ways. One way that we check, so whenever we roll out the build to the user, we check the Crashlytics Fabric, whether our build is successful release or not. It's based on your crashes, how many crashes that you are showing. Another is that to improve the app stability, adapt the stage rollout. Don't do the 100% rollout at one time. Go slowly, adopt the stage rollout. Make it live for 1%, 5%, 10%, then 50% of user. Adopt to Kotlin for the null safety and less code. Use parcelize. In our cases, we figure out many exceptions are coming due to bad parcelize exceptions. Don't have any way to figure out if developers are correctly doing the parcelization, read and write. We started using one library, parcelize, which help us doing that. If you use a parcelize annotation, it by default handle the read and write for you for the parse level operations. By adopting to it, we have seen the serious reduction in terms of bad parse level exceptions we are getting in the production build. If you are using the app bundle, please do add multi-split check. If your app is getting shared through non-Play Store verified devices, it will start crashing. We added the check, and we figure out that in Vivo Store, our app is only the base APK is presented, and when people are installing and launching the app is getting crashed. So we added that support. Integrate lint. So lint is a static code analysis tool. You can't add it for the complete code base, so just create the baseline. Once you create the baseline, going forward, only the new issues, it will give the warning for that. Why we added the lint as well is that we wanted to support the localization and try to figure out how many hard-coded strings are present in the app and how we can avoid it. We have the Sonar lint tool as well that will provide the same thing. It will give a lot of warnings, lot of errors, which you can fix and figure out the things. At one places, we are facing the issue with the transaction too large exception as well. It happens when you are trying to pass a lot of data over the bundle to the activity or the fragment. So how we fix it is that for passing the data over the bundle, instead of passing that data over the bundle, we started storing that in the file, DB, or any other operations that help us passing the large volume of data from one part to another. Studio also provides the warning for the null pointer exception. So if you're using the Java code, you see the Studio will provide the warning whenever Studio figure out it's a null pointer exception. So whenever you open the file, see the yellow warnings on the right side of the Studio. Check the Android vitals in the Play Store. We have enabled the leak and the FPS build in our debug so that it will always give the memory warnings, plus how the frame per second is working in our app. So with all that optimization, we are seeing like 99.91% crash-free session for all our app versions. And for the top builds, it's like 99.95%. We also tried out Litho for flat hierarchy. So we are seeing developers are making a mistake in doing a lot of layout hierarchy. There's no way you can figure it out in the code review. Migrated to Litho, and we have seen some major improvement in terms of the layout hierarchy. If you see the left view is the without Litho, right view is with Litho, and the hierarchy is exactly the flat one. So with Litho and recycle view, we have been able to improve a lot in frame FPS. In terms of improvement in the launch and other part, we have not seen much gain. But yes, for the frame per second, we have seen a lot of gain in terms of achieving the 60 FPS with the scroll. Next come app adoption. Why app adoption is important? So most of the time, we fix the crashes, new features with the latest app. And we want user to update to the latest app as soon as possible. So we tried out few things for the app adoption. First is the in-app update, which Google recently launched. It has two methods, flexible and intermediate. So flexible, we are showing it if the user is on older build more than 30 days. We have a release cycle of 2 weeks. So if he is on older build, which is more than 30 days, he is already 2 builds behind. So we show the flexible option to him. If the build is older than 2 years, we show the immediate option. We want him to immediately upgrade to the latest version, because we are not supporting any app which is older than 2 years, and we don't guarantee how stable it is. We also tried out few things, is like we try to roll out the build to 100% of user on Friday morning, and when we come on to office on Monday, we've seen the adoption of like 40% to 50% just in 2 days. So most of the people during the weekend gets auto update of the app if you do it on the Friday. Better new adoption, you will have more stability, more user satisfaction. And with the in-app update, we have seen like 10% of users already migrated to new app with the in-app update. So this is how we are showing the in-app update. So on the home page, we show the Croton about the bottom bar, where we will show the message to the user, app update is available, they can just click it on now. Now comes app size. Why app size is important? App size is important because if your app size is more than 100 MB, most of the people will not download it. Even if they download it, they will not retain it for long time on the device. App size needs to be as small as it can be. We have done some best practices and figure out the things that we need to do. Our present app size is like 12 MB, and we have done a lot of optimization for that. First thing is that we tried integrating the ProGuard. ProGuard everyone is using, but we just have to check whether we are using it correctly or not. Android Studio has a tool, so they have APK Analyzer tool. If you upload your release APK, check if all the files and the methods are correctly obfuscated or not. If it's not obfuscated, then the ProGuard is not working correctly. We checked it using the Analyze tool. ProGuard also has a paid version DexGuard that not only obfuscate the bytecode, but it obfuscates all the parts of your application, like assets, drawable, and every other things. If you wanted to further obfuscate the APK, you can opt out for the DEX guard. Enable the ProGuard with the minify enabled and shrink resources. And we have seen the size reduction like 5 MB with ProGuard, minify enabled, and shrink resources. App bundle. We applied the app bundle on top of ProGuard. So app bundle will, by default, provide the density, architecture, and the language split for you. You don't have to upload different APK for it. Now, when we adapted for the app bundle, we have seen like 3 to 5 MB reduction in the app size because it's giving the density and architecture update by default. What exactly is Redux? Redux is an open source tool from the Facebook. It will run on top of your app bundle. It will recheck your DEX files, and based on the DEX file, it will recheck the DEX file, recompile DEX file again, and it will give you the improvement on size on top of app bundle. So when we ran the redex on top of our app bundle, we have seen like 200 KB improvement. So it basically recompiled the DEX and figure out the unused resources in the DEX file and give the improvement on top of that. It also has feature like it will figure out the primary DEX file, what are the methods needs to be present in primary DEX file, which are needed for the app launch, and based on that, it will rearrange the DEX code and help improve in the app launch time as well. So that is the open source tool from the Facebook. Benchmark. So you can benchmark app size with every commit as well. Jenkins has a plugin available, APK Analyzer plugin. You can integrate it, and it will give you the app size with every single commit that you are making in your code. You can change the app size with every app release in the Play Store as well. Play Store now started providing the app size graph with every app release. Other is image bundling. What we have done is that all the images which we are bundling in the app, we migrated it to WebP. We started using the SVG for the icons. If we are bundling any image which is more than like 50 KB, 100 KB, we raise the alert during the code review itself. We stopped bundling the heavy images in the app. What we have done is that we are lazily loading that image over the network when it's required. Play Store warnings. Play Store recently started giving the warnings. If you are not following all of these practices, it will show the red sign there. So we are following the code chunking of obfuscation. We are following the ABI configuration, screen density, language. It also gives the error when you see the app size if you are bundling any image which is of size more than 1 MB. We have seen the cases where the developers are adding up, bundling the 2 to 3 MB image with the app without any reason. And the image itself is not compressed. Now comes the last part, summary. So we have now the faster app launch time with all that best practices. No more waiting for the user to place the order. We have optimized our network payload, low data consumption for the user. We are downloading less data over the network, less memory footprint on the device. If we are downloading the less data for the image, the caching will also be much more sufficient. More QPS we can support at the server end. So we have the code running on the server. Now the response time is being reduced down. The server can support more QPS with the same number of boxes. And another is cost optimization. We don't need any more resources, any more boxes at the server end to support that many QPS. Developer time optimization. So we have like 3.5 seconds of time for the fresh debug build and 1.1 second time for the incremental build. For the release build, it's taking 5 minutes of time. We use the Slack, Jenkins, and the fastlane for building the release build. So it's not blocking the developer time for building the release build. Better user adoption experience. We have like 99.91% crash-free session for all the app versions. We have 80% adoption for latest 2 app versions that we released in the last month. And our app size is 15% smaller as compared to our peer apps. So basically, you can go in Play Store, check the peer apps, and compare the data, how your app size is comparable as compared to your peers. Lesser the app size, lesser the data plus time to download the app. all this will result in the better app rating in the Play Store, plus more number of installs for your app. We have the blocks for all of these. So if you see, we have written the blocks for all of this on the Medium. You can find the blog on the app size, litho performance, app launch improvement, how we have done the web view optimizations, and then litho improvements. So all that, we have the blocks on the Medium. We also added the picture-in-picture mode for Oreo Plus devices. Yes, that's all.